The universe is literally screaming at us. So here's the thing about space that keeps astronomers up at night. And I'm not talking about working late shifts at observatories. The universe is absolutely bombarding us with radio signals. And the best explanation scientists can come up with for most of them is basically a shrug. And maybe it's magnetars. Now, if you're thinking aliens, hold that thought, because the truth is actually way weirder. Let's start with fast radio bursts, or FRBs as the cool kids call them. These are essentially cosmic screams that last for just a fraction of a second, but release as much energy in a millisecond as our sun puts out in 3 days. The first one was discovered back in 2007 by astronomer Duncan Lorimer and his student David Narkovich when they were digging through old data from the Parkes Radio Telescope in Australia. They found this insanely bright pulse of radio waves that seemed to come from absolutely nowhere, traveled billions of light years across space, and then just vanished. Scientists have now detected hundreds of these things, and they're still debating what causes them. Neil deGrasse Tyson has talked extensively about how the universe constantly surprises us with phenomena that challenge our understanding of physics, and FRBs are the perfect example. These bursts are so energetic that by the time they reach Earth after traveling across billions of light years, they're still detectable. To put that in perspective, by the time these signals arrive here, they're about 1,000 times weaker than what you'd get from a mobile phone on the moon. And yet we can still pick them up. That tells you just how ridiculously powerful these events are at their source. Charles Liu, the astrophysicist from the American Museum of Natural History, who co-wrote books with Neil deGrasse Tyson, has emphasized how cosmic mysteries like these push us to reconsider what we think we know about the universe. Some fast radio bursts repeat in seemingly irregular patterns, which completely messed with our theories. Because if these are caused by catastrophic events like exploding stars, they shouldn't repeat at all. Explosions tend to be one-time things. In 2022, scientists using NASA's NICER and NuSTAR telescopes actually caught one of these bursts in the act. They were watching a magnetar, which is basically a neutron star on steroids, with a magnetic field so powerful it could erase your credit cards from halfway across the solar system. This magnetar, with the catchy name SGR 1935 plus 2154, started acting weird. It began spewing out X-rays and gamma rays like a cosmic disco ball, and then suddenly, boom, it released a fast radio burst. If you're enjoying this deep dive into cosmic mysteries, hit that subscribe button and ring the notification bell so you don't miss our upcoming videos on black hole collisions and what happens when galaxies eat each other. Trust me, it's even more insane than it sounds. The magnetar mystery and what it tells us. Here's what makes magnetars absolutely terrifying and fascinating at the same time. These things are so dense that a teaspoon of their material would weigh about 1 billion tons on Earth. We're talking about the collapsed core of an exploded star, compressed down to maybe the size of Manhattan, but containing more mass than our entire sun. The gravity is so intense that if you dropped a marshmallow onto its surface, it would hit with the force of an early atomic bomb. Yeah, you read that right. A marshmallow. The surface of a magnetar is basically the most violent place in the universe that isn't actively exploding. It's constantly releasing bursts of X-rays and higher energy light, and the magnetic field is so powerful it defies our understanding of physics. To give you some context, Earth's magnetic field is what makes compasses work and creates those beautiful auroras. A magnetar's magnetic field is a quadrillion times stronger. That's a 1 with 15 zeros after it. At that strength, the magnetic field literally warps the shape of atoms and tears apart the space between them. But here's the controversial part that scientists are still arguing about. When that magnetar released its fast radio burst, it also did something strange. It suddenly slowed down its rotation, like someone hit the brakes on a cosmic merry-go-round. Scientists think this might have been caused by the magnetar essentially burping out material from its interior into space, like a volcanic eruption, but on a star. The leading hypothesis is that the magnetar's crust cracked, releasing material and causing the whole thing to decelerate. But here's the kicker. Before this glitch happened, the magnetar had been releasing X-ray bursts left and right, and none of them produced a fast radio burst. Only after the slowdown did we get the FRB. George Jonas, a researcher at NASA's Goddard Space Flight Center who studies magnetars, put it perfectly when he said they've unquestionably observed something important for understanding fast radio bursts, but they still need a lot more data to complete the mystery. That's the frustrating beauty of astronomy. Sometimes you catch the universe doing something spectacular, and you're still left scratching your head, wondering what just happened. When the universe blinks at us on a schedule. Now, if you thought fast radio bursts were unusual, buckle up, because we're about to talk about something even stranger. Scientists have discovered objects in space that are essentially cosmic metronomes, but instead of keeping time for a piano player, they're beaming radio waves at us on incredibly long, precise schedules. And our current understanding of physics says these things shouldn't exist. The first of these long-period radio transients was discovered in 2022, and it was pulsing every 18 minutes and 18 seconds with metronomic precision. Each pulse lasted between 30 to 60 seconds, which is bizarrely long for a cosmic radio signal. But what really baked everyone's noodles was that the brightness of each flash varied wildly from pulse to pulse. Sometimes it would shine brilliantly. Other times it would barely register, and occasionally it would just skip its scheduled broadcast entirely, like it overslept. Fast forward to more recent discoveries, and astronomers found an even longer period object. This one, designated ASCAP J 1935 plus 2148, pulses every 53.8 minutes. And it doesn't just pulse, it cycles through 3 completely different personalities. Sometimes it shoots out bright flashes lasting between 10 and 50 seconds with linear polarization, meaning all the radio waves point in the same direction. Other times, its pulses are much weaker with circular polarization, lasting just 370 milliseconds. And sometimes it just goes completely silent, missing its cue like a forgetful actor. Dr. Manisha Caleb from the University of Sydney, who led the study on this object, said it's highly unusual to discover a neutron star candidate emitting radio pulsations in this way. The fact that the signal repeats at such a leisurely pace is extraordinary. And she's right to be excited, because according to our current theories, a neutron star spinning once every hour shouldn't produce radio waves at all. The physics just doesn't work. It's like finding a car engine that runs on nothing but good vibes and optimism. The red dwarf revolution. Recently, astronomers managed to track one of these mysterious long-period signals back to its source, and it wasn't a lone neutron star or a magnetar or anything quite so exotic. It was a binary system, a red dwarf star paired with a white dwarf, basically a stellar odd couple sharing an apartment in space. Red dwarfs are the universe's most common stars, small, cool, and capable of burning for trillions of years. White dwarfs, on the other hand, are the leftover cores of dead stars, super dense objects about the size of Earth, but with the mass of our Sun. When you put these two together, peculiar things happen. The red dwarf produces a stellar wind of charged particles, kind of like our Sun does, but less dramatic. When that wind hits the white dwarf's magnetic field, it gets accelerated and produces radio waves. Scientists already knew about systems like this. There's one called AR Scorpii, where the white dwarf is hitting its red dwarf companion with a powerful beam of radio waves every 2 minutes. But none of these known systems are as bright or as slow as the long-period radio transients astronomers have been finding. This discovery is forcing scientists to reconsider decades of understanding about how neutron stars and white dwarfs emit radio waves and what their populations look like in our Milky Way galaxy. Charles Liu has always emphasized in his work how colliding and interacting systems in space teach us the most about the universe. And these binary star systems pumping out mysterious radio signals are perfect examples. They're showing us that the cosmos has more tricks up its sleeve than we ever imagined. The WOW signal, 48 years of cosmic confusion. On August 15, 1977, the Big Ear radio telescope in Ohio picked up something that made astronomer Jerry Eman literally write "wow" on the printed data. That exclamation became the name of one of astronomy's greatest mysteries. The signal was a strong narrowband radio transmission that lasted 72 seconds, broadcasting at 1420 megahertz, the natural frequency of hydrogen. Back in 1959, physicists had theorized that any alien civilization trying to communicate via radio would probably use this frequency because it would be familiar to any technologically advanced species. The signal was so strong, so precisely tuned, and so exactly what scientists were looking for that many people jumped to the obvious conclusion: aliens. Except the signal never repeated. Despite numerous follow-up searches, nobody has ever detected anything like it again from that region of space. Then in 2024, a team from the Planetary Habitability Laboratory at the University of Puerto Rico came up with a fascinating hypothesis. Led by Abel Mendez, they analyzed archived data from the former Arecibo Observatory and found multiple instances of weaker signals similar to the WOW signal. Their theory? A cold hydrogen cloud got blasted by a powerful burst of radiation from something like a magnetar flare, causing the cloud to suddenly brighten and emit a laser-like beam of radio waves in a phenomenon called a maser. The Big Ear telescope just happened to be pointed at exactly the right spot, at exactly the right moment to catch this cosmic fireworks show. Not everyone is convinced. Michael Garrett, chair of the International Academy of Astronautics' SETI Permanent Committee, said it feels a bit contrived because several improbable things needed to happen simultaneously. But it's the best natural explanation we have so far. And here's the controversial part. If this theory is correct, we might have been chasing a phantom for 50 years. The signal that everyone thought might be aliens could have just been the universe's version of a cosmic burp. The object that shoots different flavors of radio waves. Let me tell you about ASCAP J 183-2-0911, because this thing is legitimately bizarre. Discovered using the Australian Square Kilometre Array Pathfinder telescope, this object does something that has astronomers completely stumped. Every 44 minutes, it wakes up and spits out pulses of both radio waves and X-rays for 2 straight minutes. Then, it goes silent again. Andy Wang from Curtin University, who led the discovery team, said this object is unlike anything they've seen before. The fact that they caught it emitting both radio waves and X-rays simultaneously is huge, because any theory that tries to explain this thing now has to account for both types of emission. It's not enough to explain just the radio waves or just the X-rays. You need to explain both, happening at the same time, in a pattern that repeats like clockwork. The leading candidates for what this object might be are either a very unusual neutron star or a white dwarf doing something we've never observed before. But here's the problem. Neither of those explanations fits comfortably with what we know about how these objects should behave. It's like finding a dog that meows. Sure, it looks like a dog, and it mostly acts like a dog, but that meowing thing really throws off your whole understanding of what dogs should do. Dr. Nanda Raya, an astrophysicist at the Catalan Institute for Space Studies, pointed out that the discovery of this object's X-ray emission opens fresh insights into its mysterious nature, and that's the exciting part about astronomy. Sometimes you discover something so peculiar that it forces you to question your fundamental assumptions about how the universe works. What this all means for us down here. All of these mysterious signals, from fast radio bursts to long-period transients to the wow signal, are telling us something important. The universe is far more complex than we ever imagined. Neil deGrasse Tyson has spent his career emphasizing that the cosmos is under no obligation to make sense to us. And these signals are perfect examples of that cosmic indifference to our understanding. But we're getting better at detecting these things. New radio telescopes like ASKAP in Australia, MEER-KAT in South Africa, and the upcoming Square Kilometre Array are going to find more mysterious signals. With machine learning helping to sift through massive amounts of data, we're entering a golden age of discovering cosmic weirdness. Charles Liu often talks about how galaxies are to the universe what cells are to the human body. These mysterious radio signals are the same. Each one tells us something new about extreme physics and matter under conditions we can't recreate on Earth. The debate isn't about whether these signals are real. They're definitely real. The debate is about interpretation. Are fast radio bursts caused by multiple different events? Or is there one unified explanation? Every time we think we've got these signals figured out, the universe throws us a curveball. That's why astronomy is simultaneously frustrating and exhilarating. You're trying to understand objects billions of light years away that exist in completely alien environments. You can't run controlled experiments. All you can do is collect light, analyze it, and piece together what's happening from incomplete information. The human element in cosmic discovery. There's something beautifully human about our quest to understand these signals. We've built massive radio telescopes and invested billions of dollars, all to listen to the universe whisper its secrets. And when we hear something we don't understand, we don't give up. We build better telescopes, develop new theories, and slowly, piece by piece, figure it out. The wow signal was discovered by someone manually reviewing printed computer data, circling interesting readings with a red pen. That's the 1970s version of scientific analysis. Today, we have computers processing trillions of pixels of information in near real time, machine learning algorithms flagging potential discoveries, and international teams collaborating across time zones. The technology has evolved dramatically, but that fundamental human curiosity remains the same. And here's something that doesn't get talked about enough. These discoveries are often made by people you've never heard of. Sure, famous scientists like Neil deGrasse Tyson explain these phenomena to the public, which is incredibly important. But the actual discoveries? Made by grad students processing data at 3 in the morning, by postdocs running statistical analyses, by engineers maintaining the instruments. In one recent long-period transient discovery, an undergraduate student named Shanad Horvath at Curtin University processed data covering half the sky and found one. An undergraduate. That's the beauty of modern astronomy. You don't need decades of experience to make a groundbreaking discovery. You just need access to the data, the skills to analyze it, and the patience to look through cosmic static until you find that one signal that doesn't fit the pattern. Where do we go from here? The future of understanding these mysterious signals is incredibly exciting. The Square Kilometre Array, once it's fully operational, will be the most sensitive radio telescope ever built. It will be able to detect signals that are currently invisible to us, and it will find these cosmic broadcasts at an unprecedented rate. Scientists estimate it might detect thousands of fast radio bursts per day once it's online. But quantity isn't everything. What we really need is quality follow-up observations. When a telescope detects one of these bursts, we need to immediately point other telescopes at that same spot in the sky to gather more data. We need to catch these events in multiple wavelengths, from radio to visible light, to X-rays, to gamma rays. Because the more information we have about each event, the better chance we have of figuring out what causes them. There's also a growing network of amateur radio astronomers who are contributing to this research. The WOW at Home project, inspired by the search for signals similar to the WOW signal, uses small, relatively inexpensive radio telescopes that people can set up and operate themselves. These systems cost around $500 for a complete setup, and they can operate autonomously around the clock. They're not as sensitive as professional telescopes, but they can monitor the sky continuously, which is something large professional observatories can't do because telescope time is precious and has to be shared among many different research projects. This democratization of astronomy is one of the most exciting developments in the field. You don't need access to a multi-million-dollar telescope to contribute to cutting-edge research anymore. You can build a setup in your backyard and potentially detect something that helps solve one of astronomy's great mysteries. So where does this leave us? We're still figuring it out, and that's okay. The universe is far more active and dynamic than we once thought, filled with violent, energetic events constantly reshaping the cosmic landscape. Every mysterious signal is a piece of a larger puzzle, teaching us about extreme physics and matter under conditions we can barely imagine. Maybe some of these signals really are from alien civilizations, or maybe they're all natural phenomena. Either way, they're absolutely fascinating. The universe has an infinite capacity to surprise us, and somewhere out there, signals are traveling toward Earth right now that will completely blow our minds when we finally detect them. If you made it this far, smash that subscribe button and drop a comment below, telling me which cosmic mystery blows your mind the most. Until next time, keep your eyes on the skies.